Hello and welcome to session 3 of our fractions courses, which are looking into the Orange Book, Developing Fractions Knowledge by Hackenberg, Norton and Wright, and digging a little bit deeper into the key chapters within the book. Today we're going to be looking at the chapters on fractions as numbers and equal sharing of multiple items. Our aim is to provide a deepened understanding of fractions pedagogy and also to provide understanding on how practitioners can assess and promote fractional knowledge and understanding through clear understanding of the concepts within this book. So a little bit of revision first. So at the beginning of today's session, we're going to revise some of the strategies we've already looked at. We're going to look at some of the key concepts we've already covered in previous courses and then see how that then links in to providing even more deepened understanding of fractions ourselves so that we're able to assess really clearly where the children are at in their learning and also in order to bring them forward. So looking at the mental actions in developing fractional knowledge, these 4 key mental actions are unitising, partitioning, disembedding and iterating. So chapter 8 is all about thinking about fractions as numbers, which we've talked about a little bit in the previous courses. So what do we mean really in more detail by fractions as numbers? So this chapter 8 in the book, explores pupils being able to see fractions as multiples of unit fractions. For example, for these children, 3/5 is 3 times 1/5, or 7/5 is 7 times 1/5. And we've looked at that in previous courses, the previous 2 courses, as being really key elements of the children's understanding and learning. The meaning of fractions is critical because, as stated at the last session, a part-whole meaning for 7/5 does not always make sense to students. Furthermore, when fractions are multiples of unit fractions, they become numbers in their own right for students. They become units in their own right, just like a number is. So in chapter 8, which is page 98 of the book, says for a student to be secure in this scheme of knowledge, they need to be able to see 7/5, for example, as a unit of 7, 5 of which make the whole, which is what we explored earlier on in earlier courses, but chapter 8 really delves deeper into that as the children seeing that unit as a number in its own right. So we've looked at this before, so just a little bit of revision. Can you work out 7/5 when you know the whole? We know 5/5 make the whole, so 7/5 is more than the whole. It's 1 2/5. A good way to introduce this learning is with the manipulative that we've looked at before, called Cuisenaire rods. These allow for the linear model to be used in demonstrating the fraction. They also allow children to easily draw their understanding in a bar model. So again, let's get our Cuisenaire rods and try some problems as a quick review of our previous knowledge and understanding. So this problem is letting us identify the unit fraction and the whole when given the composite fraction. So if the black bar is 7/8, which bar is the whole and which is the half? Pause the video to solve the problem and we'll look at the solution. So if the black bar is 7/8, which bar is the whole and which is the half? So we'd need to iterate 1 bar 7 times to work out what 1/8 is. So the white bar is 1/8. 7 of those make the black bar, 8 of those will make the whole, which is the brown bar. So 1/2 would be 4 of those 8. So already we're starting to think about equivalent fractions there, and we can start to introduce that language now. 4/8 is the same as 1/2, which is the pink bar. You can see how using the Cuisenaire rods can quickly lead on to the use of bar models to visually represent thinking. And we can also see how the use of those Cuisenaire rods and the bar model can really clearly show that relationship between 4/8 and 1/2. That those two they can think about it in terms of simplifying a fraction or looking at an equivalent fraction. So our next problem, if the pink bar is 4/5, which bar is the whole and which is the fifth? We're identifying the unit fraction and the whole when we're given the composite fraction. So if you pause the video to solve the problem, then we'll look at the solution. So the pink bar is 4/5. How are we going to work out the whole? We need to iterate a bar 4 times to see which bar is worth 4/5. So you can see the white bar is 1/5. We iterate it 4 times to get 4/5. One more time to get 5/5, which is the whole. We can then use that unit fraction of the white bar to iterate twice to work out that the red bar is worth 2/5. We're now thinking about, we're going over again and reviewing, we're solving problems that involve improper fractions. Fractions that go beyond the whole, that are bigger than the whole. So if the blue bar is the whole, which is 10 ninths, just like composite fractions, to work out the improper fraction, you need to first of all know the unit fraction. So we'll pause the video so you can try and solve that problem. So if the blue bar is the whole, which bar is 10 ninths? So the whole will be 9 ninths. We need to work out the unit fraction. So 9 ninths make the whole, so it's 9 of the white bars. We need 10 of those white bars to make 10 ninths, which is equal to the orange bar. The orange bar goes beyond the whole, and it's worth 10 ninths. Can you write this as a mixed number fraction? What would 10 ninths be as a mixed number fraction? It would be 1 for one whole with 1 extra ninth, so 1 and 1/9. And it's a good way for the children at this point to be able to compare those two and see how they link together. Our next problem, if the red bar is the whole, what is 9/2? So we're given the whole bar and we're going to produce a composite fraction or an improper fraction of the whole. Again, when we're solving improper fractions or composite fractions, we first of all need to know the unit fraction. If you pause the video to solve that problem, and then we'll look at the solution together. Solving that problem, we need to first of all think about the red bar as being the whole. What is 9/2? So we first of all need to work out what is 1/2. 1/2 would be the white bar, because 2 of those recreate the whole. So we need 9 of those halves now. So there's 4, 5, 6, 7, 8, 9 halves. What is 9 halves? What are 9 of those white bars equal to? They're equal to the blue bar. So the blue bar is the equivalent of 9 halves. There's the whole. So what is that as a mixed number fraction? We can fit 4 wholes into there with 1/2 left over. So as a mixed number fraction, it's 4.5. 9 halves is equal to 4.5. Here's a problem we looked at last time. A contextualised problem about the chocolate bar, and can you create a new chocolate bar that is 7/5 of that bar, which is developing on the skills we've just looked at with the Cuisenaire rods. So first of all, we need to divide the whole bar into 5/5 to work out 7/5. We then know that those 5/5 make the whole, and another 2/5 make our 7/5, which create our new chocolate bar. And we can see that clearly with the bar modelling, just like we looked at last time. So mathematisation of this problem, so a way to break down this problem would be whether the children use solely bar models to solve the problem, or whether they require materials like paper strips. So that's when, at this point in your kind of journey as a teacher, you're thinking about, right, how am I going to scaffold that problem? What kind of materials am I going to put out to use for the children to use as a support? Paper strips are really good. Being able to really kind of embedding that, being able to draw those bar models clearly before giving them a problem like this. Otherwise, a problem like this is going to be quite tricky for them either to solve or to be able to prove, to justify their reasoning for being able to solve it. The bar models are really important. How are you going to scaffold that for the children in your class? Visual representations are really, really important with all of these problems that we've looked at so far today to be able to prove and justify their solutions. It's helpful to ask questions about the pictures they've drawn to make them then dig more deeply into the bar models that they've drawn as solutions. So what's the fractions name of the bar you drew? Can you show all the parts in your new bar? How did you know how long to make the new bar? Can you shade 1/5? Pupils will often ask which bar. Doesn't matter. Any of those bars are 1/5. Doesn't matter if it's in the middle or at the beginning. And that understanding that 1/5, it doesn't matter that there are 7 parts, it's not now a 7th, because quite often they'll do the whole problem, but they'll still want to label it as a 7th because they forget about that hole in the middle there. So that your questioning is really, really important to kind of dig a little bit deeper into the children's understanding and where they're at in their journey, where they're at in the processing of that problem. This type of question also leads on to children being able to annotate their bar models with their thinking, their understanding, fractional notation, and the strategies they've used to work out each problem. This is an extremely useful assessment tool for you as a teacher. Here's an example of one of the children in my class solving some of those task cards that I was showing you earlier. And you can see here that they've really put a lot of detail into the annotation. This lets me see exactly where they're at in their journey and their understanding. We've also then included a pupil voice on there as well, so they've been able to peer assess each other's work. So other children would then look at each other's work to assess it and to see, actually, I think you could have included more detail there, or that detail wasn't exactly correct. You need to adjust your wording on that to make it really clear. How often do we look at a child's piece of writing and get them to go back and peer assess it, self-assess it, then make changes? Annotating these bar models allows that same process to take place within a maths lesson, and it then becomes more of an inquiry type task rather than just a set problem with a set solution. We can really dig deeply into understanding and being able to justify children's reasoning and how they came about that solution. So the next stage in the knowledge and understanding in this chapter is about creating a fraction number sequence and comparing it to whole number sequences. There are opportunities for generating proper and improper fractions by iterating a unit fraction on a number line, which supports their understanding of fractions as numbers on number lines, and that or how they would be ordered in that way. So the task for this one is to give each student a fraction strip, which will be the whole. And they're going to create a 1/4 bar using the fraction strips. Now create a 2/4 bar. Keep doing this up to 12 quarters, and then see if they can notate that on a number line. So if you draw an empty number line, they can use that to order the fractions and investigate their findings. And they might end up with something looking like this. So they can see 1/4, 2/4, 3/4, 4/4. Then going into the improper fractions of 5/4, 6/4, 7/4. You can keep going. The fraction doesn't have to end at 4/4 when you get to the whole. We can keep going, we can keep going, we can keep going, right up to 12/4. They can say how many numbers are in the fraction sequence. That 9/4, they're seeing it as a number in its own right. They're seeing it as a unit in its own right. What are the similarities and differences between this and a sequence of whole numbers? It's a really good question to ask children. As adults, that's a difficult question to answer. They will actually see more links in that than often we do, because we don't tend to see fractions as something you can order. How many fraction sequences are there? We can then look at comparing fractions. So which is bigger? Predicting or comparing the difference in size between composite fractions of the same whole. And that's what we were talking about when we were looking at ordering fractions before. We can't order and compare fractions unless they are compared to the same whole. Predicting and comparing how different improper fractions determine the length beyond the whole. So first of all, starting with composite fractions, which is bigger, 4/5 or 3/6? Once they have a really strong understanding of fractions and they've done lots of work looking at fractions walls like we've looked at in the previous courses, they can then start to almost mentally disembed these fractions in their mind's eye and be able to solve it by using that knowledge that they already have. So if they're thinking, well, I know 3/6 is the same as a half. 4/5 is more than a half. So therefore 4/5 is going to be larger. So they're starting to predict, first of all, which one is largest, and then justify that prediction, justify that reasoning using visual representation or fraction strips. So they're starting to be able to justify, can provide visual proof for their conjectures. Which is bigger, 4/3 or 5/4? By using the knowledge they already know with these improper fractions, that a third is bigger than a quarter, they can then start to make reasonable predictions and they can start to be able to prove that conjecture using bar models, using number lines and fractions on those number lines. It starts to make more sense and they're then able to do that in a mental capacity rather than having to get out the fraction walls, rather than having to get out the fraction boards that you might have had to do previously for them to be able to make sense of that problem. So a way they might be able to prove this is with bar modelling. So 4/3 would look like this, where we've got a whole and one extra third. Whereas with the other problem, we can half it and half it again to create the quarters. And one extra quarter. We can see really clearly there that the whole and 1/3 is bigger than a whole and one extra quarter. That really deep knowledge and understanding of improper fractions leads the children to be able to work out this problem with a lot more understanding. By using visual representations, children can more easily understand why 4/3 is bigger, even though the numbers are smaller, which is a common misconception. They look at the numbers in the other fraction and think automatically it must be bigger. So bar modelling is really important, as I keep talking about all the way through all of these courses. This knowledge of fractions numbers in their own right can then be transferred, allowing children to solve fractional number problems. So here's a problem here, a word problem. Amelia has to raise £60 and has raised a quarter of this amount. How much has she raised so far? So we can use that knowledge of fractions, that knowledge of bar modelling, to allow the children a strategy to visually break down the problem and solve it step by step. So £60 is our whole amount. So that's the whole amount she has to raise. She's raised a quarter of it so far. So we can split that whole amount into quarters. Half of that, they might already be able to work out that to work out a quarter, we half it and half it again. That's the same with numerical problems. So half of that is £30. So half again is 15. So Amelia has raised £15 so far. Let's look at a trickier problem. Mrs. Little had £1,000, if only. She wants to spend a quarter of it on new books and a third of the remainder on maths resources. She used the rest for art supplies. How much did she spend on art supplies? Now, that is a complicated problem, and when you read it out, it sounds like there's so much to it, and it's hard to make sense of that word problem. So what you know what I'm going to say, bar model is a great way of breaking down that word problem into manageable steps. So let's have a look at how that would look as a bar model, breaking down each step as we go. So Mrs. Little has £1,000. That's our whole amount. So we write that at the top of our bar model. She spent a quarter of it on new books. So let's split that into quarters. So half of the 1,000 would be 500. So half again, 200. I've spent that on new books. I want to spend a third of the remainder. So the remainder is 750. It's the three other 250s. 3/4 that's left. I'm going to spend a third of that remainder on maths resources. So that means I'm going to spend 250 because the 750 split into thirds is 250. The rest is for art supplies, which I can clearly see there. I can pop it in, and when I put my other 2/3 in as 250 and 250, that gives me £500 to spend on art supplies. So by drawing it out step by step, you can actually solve that problem pretty simply, when actually the wording of it is a bit more tricky. It allows far more easy understanding and breaking down of word problems when you can visually represent it like this. So further tasks. For further instructional activities and assessment tasks on fractions as numbers, these are on page 103 to 109 of the Orange Book, and there's some really lovely activities in there that you can use just to really develop and hone in on really allowing the children to access these skills and this understanding. So our next chapter is chapter 9 of the book, and it's about equal sharing of multiple items. We've already covered this a little bit with distributive reasoning that we've looked at in previous courses. So we're going to go over a little bit of what we've already learned and then show how the children will move through this skill step by step, and how you can support them into coming to the most efficient strategy and the strategy that allows them to really give a proper fractional amount for our solutions to problems. So after sharing single items equally, a next step is to share multiple identical and non-identical items equally. For example, sharing 2 granola bars between 3 people is quite a difficult problem to fathom, even at the best of times. How can we do that systematically and mathematically? Children need to be at the 5th level of fragmenting to be able to solve these problems, which were touched upon in session 1 when we looked at the different stages of fragmenting. So we will look at a range of problems and review student solutions and demonstrate the difficulty and the mathematisation, so the way we can break down these range of problems. So here's a problem that we might give the children to try and solve. So we're going to equally share these 3 cereal bars between 4 friends. How are we going to do that? And the first thing the children will want to do is, so I would give them this as an open task. I wouldn't be telling them how to do it. I'm not giving them a solution of how they can solve the problem. I'm leaving it as an inquiry. How can we solve these? How can we share these 3 bars between 4 friends? Again, you would start with having manipulatives out, having strips of paper out, having things that the children can physically get up, move around, touch, cut up, and manipulate. Pupils will often partition to start off with each bar into halves. They automatically want to half things. That's what they naturally go towards doing. So they've halved the 3 bars into 6 pieces. So that means each person is getting 1 half. We now have 2 halves left. So this means that each child has 1 half, and we can then partition again, each of those halves again, to create quarters. And the children will then often figure out that they can half it again to create those quarters, like we've shown in the bar at the top there, which means that they can then distribute those quarters to each person, so they end up with a half and a quarter. So the children have solved the task. This gives each child a half and a quarter. They've solved the task, but they might not be able to work out this is equal to 3 quarters. This is a key assessment point for teachers. So they've solved the problem. Absolutely, they've solved the problem. But they've worked out that each person gets a half and a quarter. But do they know that that's 3 quarters altogether? That I would be then digging down deeper with the questioning I was giving them. Can you work out what fraction of the original cereal bar they have each? How are you going to do that? They might only get to this point, and that's a good point for you to know, so you can really clearly see where they are at with their fractional understanding. Here's another one. Can you share this 4-finger Kit Kat between these 3 friends? So again, what the children will initially do is get the Kit Kat and break, as they would do in real life, break off the fingers. So they're giving them 1 finger of the Kit Kat each. But they're now left with 1 leftover finger of the Kit Kat. What are they going to do with that? The natural thing would be to third it, to break it into 3 equal parts. And there we go. Dividing up the Kit Kat amongst the friends. Each child gets 1 1/3. The children do not need to use distributive reasoning for this task because they tend to give out the whole bars first, therefore only needing to partition one bar at the very, very end. Similar problems could be 6 bars among 4, 7 bars among 4, 15 bars among 8. These problems will begin to introduce more difficult distributive reasoning, which we will now look at as a key strategy that's in the frameworks. So this is a bit of a trickier task because now we're moving away from linear bars. We've got an area model of a pizza, which is in the shape of a circle. So we're then having to transfer that knowledge that they've built up so far using linear models and put that into a different model, the model of the area model, which is in this case a circle. So 12 friends went out for pizza. It was towards the end of the month. We all know this feeling. And they only had enough money to order 8 pizzas. So they ordered 8, shared them equally. How much pizza did each person get? Now it needs to be fair. How can we work this out? Again, what a lot of children will do, and what they certainly did in my class, as it says in the book as well, was they straight away went to repeated halving to solve the problem. So this is a problem from Mike Askew's book, Transforming Primary Mathematics. It allows children to apply their knowledge from linear fractional models to an area model, the circle shape of the pizza. And this is how Sam in my class solved it. So he solved it by halving each pizza first of all. It did work in a group to do this, but this is the way that he visually represented it in his book. And he worked out that they each got a half. And then he's then split up the last 2 pizzas into 12 pieces. So there was 6 in each pizza, so they then got a 6th. He then drew that lovely model at the bottom to show what 1/2, which is equivalent to 3/6, and another 1/6 gives us 4/6 altogether. This took a long time. This was a long session. It was a whole lesson. It would lasted about an hour. It took him about an hour to get to that point. He had lots of mistakes first, which were great. The mistakes helped him to improve. He had about 4 different solutions before he finally got to a solution that he was happy with the final answer. Some children never got beyond, it was 1/2 and 1/6. They never got to that point of being able to use the area models, the visual models, to work out it was 4/6 that they each got. Still a valid answer, but you can show how it's an example of a low floor, high ceiling task where you'll get some children getting to a certain level of understanding and others are able to take it that step further by then giving that fractional amount at the end. Other problems could include 2 shared among 4, 7 shared among 8, and to scaffold it in that way. So using distributive reasoning. Distributive reasoning is sharing each of the bars equally. For example, here we've got 5 identical cereal bars shared between 7 friends, which is the cereal bar problem from page 112 of the Orange book. And what they've done is they've put in worked examples of the kind of solutions that different children in their research have given to this particular problem. So Karena divided each bar into 7 and then given 1 part to each child. So she had the original 4 bars shared between 7, and so what she's ended up with each child getting 5/7. Here's an example where the child solved the problem by trying and testing and playing around. This is referred to in the Orange book as a system called bricolage, which is similar to repeated halving, but it has, because of the nature of this specific problem, that it's 5 divided into 7, it's not as simple as just halving it. You have to do it quite a lot of times. So it's the bricolage, is that building up of halving it, then dividing it again, then dividing it again. And I'll show you what I mean by that. So first the child has partitioned each bar into halves. Then they've partitioned the leftover bars into thirds, effectively 6, leaving 2/6 spare. You can see with the arrow there. Next, they've partitioned the 2 leftover parts into quarters, then leaving a tiny wee mini part at the end there. You can see with the arrow there, which she's then partitioned into 7 teeny weeny parts again. So she's ended up with a half and then a sixth, and then the part that's been divided into the 7 parts, and then the teeny weeny part. So although she has answered the problem in the same way as Karenna did, she's got a visual example of what that could look like, but she's not got the understanding to be able to change that into a fractional amount. So you can see there it consists of a half, a small part, a mini part, and a teeny weeny part. She still solved the problem, but not in a way that mathematically makes particular sense. It's unlikely with this strategy that a student will be able to determine a fraction name for the share. She's able to describe it as a half, a small part, a mini part, and a teeny weeny part. She's not able to give it a fractional name. She has still solved the problem though, so it's still a valid solution to the problem. A way of kind of digging down deeper into this, at second level, third level problem, is this is more of an inquiry-based approach. So it's giving a real life context for a problem, again, like the cereal bars. And it's from a book called Mathematicians at Work, Constructing Fractions, Decimals and Percents by Fosnock and Dolk. And the context that they've used for this problem is a sub-sandwich. And it's a sub-sandwich on purpose because you can see again it's that linear shape. And so the problem is that children are going on a school trip, and there are 4 children going to the National History Museum. They have 3 sandwiches to share. There are 5 children going to the Museum of Modern Art. They have 4 sandwiches to share. There are 8 children going to the Statue of Liberty. They have 7 sandwiches to share, and 5 children at the planetarium have 3 sandwiches to share. So which group got the most? Was it fair? How much did each child get as a fraction? So they're going to calculate the fraction of the sandwich each child will get in the group. They need their success criteria. They need to show visual proof of their solution, and they need to work cooperatively with their team to solve the problem. It's quite a difficult problem to solve, but it's using that distributive reasoning understanding to be able to solve it. And this is the way in Fosnock and Dolk's book that the children in their groups solved the problem using a visual representation. Now, before they showed this as a visual representation, they worked it out using paper strips. They were given paper strips, scissors, they were given rulers, they were given lots of different manipulatives to be able to solve the problem before they then recorded it visually with these visual representations. And you can see straight away that this group have done the same thing of repeated halving and that bricolage method that's discussed in the Orange book. So for the first one, where they've got 3 baguettes that they've shared between 4 people, they've halved it first of all, and each person has ended up with a half and then a quarter, which can be easily compared to the fourth group where they've ended up with a half and a tenth. And you can see that the half and the quarter is obviously more. You can see in the second group, they've really done that bricolage method of dividing each into halves first of all, and dividing their final one into fifths. And the leftover half, they've divided into 5 parts, which is a tenth. So they've then got lots of different fractions to put together. Are they able to write that as a fraction in its own right? I'm not sure. It starts to get more and more complicated when you're solving problems like this. So they've used repetitive halving, partitioning, the bricolage method as described in the Orange book to solve the problem. They have solved it, but it's a bit more complicated to be able to give a really secure final answer. You can see this group have done the same. They've used repetitive halving and partitioning to solve the problem. But the final group have solved it in a much simpler way. They've divided each baguette, each sandwich, into that number of pieces. So for the 3 baguettes divided between 4 children, they've divided each baguette into 4 pieces. So they can really clearly see it's a quarter, a quarter, and a quarter, which makes 3/4. The 4 subs for 5 people, they divided each sub sandwich into 5 pieces. So they can see it's 4/5. And they can much more easily then compare those amounts together to see who got more. What I did when I did this task with my kids in my class was each group went about it in their own way. And then we discussed at the end as a plenary session, which way is the most effective? Which strategy do you think was the most effective way of solving this problem, and why? Who was able to give the most definitive answer at the end, and why? But we also discussed that every solution was valid. Every solution still solved the problem, but we were able to have that really in-depth discussion about what was the most effective strategy, what really helped us to solve that problem the most quickly and in the most effective way. This group have used distributive reasoning to solve the problem, which is why their solution is probably the most effective way to solve that task. We then were doing, our topic while we were doing fractions in maths was Galapagos a few years ago. So I always find it's a really nice way to be able to put the maths that we're doing into the context of whatever topic we're doing. So myself and my stage partner looked at how we could look at problems that would involve our learning in Galapagos as well. So here's one where it's Charles Darwin is feeding the finches he's using for his research. He shares 3 bags of birdseed between 4 finches. What fraction of 1 bag do they each get? And it's saying there, remember to prove your solutions with visual representations. Another example of contextualised problem. Galapagos penguins' diet consists primarily of cold water schooling fish, such as anchovies, sardines and mullets. They were looking at food chains in Galapagos and the kind of food that where different animals would sit within the food chain and the kind of things they would eat. So a group of 8 Galapagos penguins eat 6 sardines. What fraction of a sardine does each penguin eat if they were split equally? So again, they can solve that using bar models and distributive reasoning. The last section of the chapter is looking at equal sharing of different sized items. And it's this whole concept of going back to parts and wholes again. And if the whole is different, the part is different, so therefore the value of that part is different. Can you share these 3 different cakes between 5 people? So because each of these whole cakes are different, have a think just now, how are you going to solve that problem using distributive reasoning? If you pause the video, have a little look at how you would solve that, knowing what we already know about distributive reasoning, and then we'll have a look at the solution. So we've got different sized items here. So that means we can't just divide it we have to look at 1 cake at a time, and we have to make 1/5 of every cake because they're different. They're going to be different sizes. If the whole is different, the part is going to be different. So let's look at 1/5 of each of the cakes. We have to divide every single one up, just like we did in those distributive reasoning problems. What do you notice about each one of those fifths? They're all different sizes. So can you justify how 1 slice of each is 1/5 of all the cakes? So you have to have one of those slices of each together, which makes 1/5 of all of those cakes. The whole amount is all those cakes of those different sizes. So in contrast to previous problems, the share is not 3/5 compared to 1 cake. It's 1/5 compared to all of the cake put together. Further tasks for this, so further instructional activities and assessment tasks on fractions as numbers are on page 119 to 124 of the Orange Book. They're really, really good, again, just like before, digging down deeper into that knowledge and understanding so that children are really, really clear. They have deep conceptual understanding and they're able to justify their conjectures when you do a variety of these different types of tasks. So our next session will be our final session in these 4 sessions about fractions, looking at the Orange Book in more detail. And this time we'll be focusing on the 4 operations, so addition, subtraction, multiplication and division of fractions. It's been lovely talking to you today about session 3, and I look forward to seeing you next time for our final session. Thank you.